Thousands of years ago, deadly viruses roamed the Earth, infecting ancient animals, thriving in long-lost ecosystems, and then disappearing beneath layers of ice. Trapped in glaciers and frozen permafrost, these microscopic invaders remained dormant for millennia. But now, as our planet warms and the ice melts, something terrifying is happening. These ancient viruses are waking up. Could a virus frozen for thousands of years still be infectious today? What happens when long-extinct microbes are reintroduced into the modern world? And could one of these ancient viruses trigger the next pandemic? In this video, we'll dive deep into the world of zombie viruses and explore whether these ancient pathogens pose a real danger to humanity. Thousands of years ago, before the rise of human civilization, viruses thrived in prehistoric ecosystems, silently infecting creatures of the Ice Age. These ancient microbes, now called zombie viruses, due to their ability to come back to life, once spread through woolly mammoths, giant sloths, prehistoric bison, and even early human ancestors like Neanderthals. Others targeted marine life, ancient plants, and microscopic organisms like amoebas and algae, shaping ecosystems that no longer exist today. As Earth's climate shifted and glaciers expanded, these viruses became trapped beneath layers of ice, frozen for tens of thousands of years. Unlike modern viruses, many of these ancient strains have never been encountered by today's immune systems and possess unique genetic structures. Some, like pandoraviruses and megaviruses, are so massive they can be seen under a standard microscope, which means they are far larger than typical viruses. For thousands of years, these ancient viruses remained locked away beneath layers of ice, isolated from the modern world. But as the planet warms and glaciers retreat, scientists are uncovering evidence that some of these frozen microbes may not only have survived, but could still be infectious. For example, scientists have successfully revived several ancient viruses from Siberian permafrost, proving that some can remain infectious even after 48,500 years. One such virus, a pandoravirus, is nearly 100 times larger than the average virus and was able to infect single-celled amoebas, raising concerns about whether more complex pathogens could also survive and resurface. Permafrost, covering 24% of the northern hemisphere, acts as Earth's natural freezer, preserving not only viruses, but also bacteria, fungi, and even the remains of long-extinct animals like woolly mammoths. However, with global temperatures rising, these frozen time capsules are breaking open. The Arctic is warming 4 times faster than the rest of the planet, leading to an unprecedented release of ancient microbes into the environment. So far, most ancient viruses discovered appear to infect only single-celled organisms. But could some evolve to threaten humans? Scientists aren't ruling it out. Unlike other life forms, viruses don't die of old age. They can remain dormant for millennia and potentially mutate to infect new hosts. The risks of ancient pathogens re-emerging are not just theoretical. In 2016, a deadly anthrax outbreak occurred in Siberia when a 75-year-old reindeer carcass, buried in permafrost, thawed during a heat wave. The Bacillus anthracis spores, which had been lying dormant for decades, were released into the soil and water, infecting dozens of people and killing over 2,000 reindeer. This event demonstrated how melting ice can awaken long-dormant pathogens, some of which could be far older and potentially more dangerous. As permafrost continues to thaw, scientists warn that unknown viruses or bacteria from prehistoric ecosystems could be unleashed, and we have no way of predicting how they might behave in today's world. The threat of ancient viruses resurfacing is not limited to microscopic organisms buried in permafrost. Beneath the Arctic's ice lie the remains of humans and animals that once carried some of history's most devastating diseases. For thousands of years, the Arctic's frozen landscapes have served as a natural time capsule, preserving the remains of humans and animals that perished from some of history's deadliest diseases, including smallpox and the bubonic plague. In recent years, researchers have uncovered traces of smallpox, Spanish flu, bubonic plague, and even anthrax in thawing permafrost. The extreme cold has kept these bodies remarkably intact, along with the pathogens that may have caused their deaths. But now, climate change is accelerating the thawing of permafrost at an alarming rate, raising concerns that long-dormant microbes could be reintroduced into the modern world. Scientists have already detected smallpox DNA in centuries-old frozen remains, proving that disease-causing pathogens can survive in ice for hundreds of years. Some bacteria, such as anthrax spores, are even more resilient, capable of lying dormant for centuries before becoming infectious again. Unlike modern diseases, these ancient pathogens haven't been encountered by today's immune systems, meaning even a mild infection could have unpredictable consequences. Beyond rising temperatures, human activity is further increasing the risk of disturbing these frozen pathogens. The Arctic is rich in oil, minerals, and natural gas, making it a prime target for drilling, mining, and industrial expansion. These activities disrupt permafrost layers, potentially releasing ancient bacteria and viruses into the environment. Studies suggest that as glaciers and permafrost melt more rapidly, the probability of unknown pathogens re-emerging also rises. A recent analysis even demonstrated that melting ice increases the statistical likelihood of a pandemic by introducing ancient microbes to modern ecosystems. Meanwhile, global warming has already triggered irreversible ice loss. Greenland's ice sheet alone is melting at a rate that could contribute to at least 1 to 2 meters of sea level rise. While the loss of ice is already reshaping coastlines and ecosystems, the threat of a reawakened disease serves as a stark reminder of the unpredictable consequences of disturbing the past. As Arctic permafrost melts, scientists are racing to study ancient viruses trapped beneath the ice for thousands of years. By extracting and analyzing ice cores, researchers can identify potential threats and assess whether these microbes could infect humans, animals, or ecosystems. In high-security labs, some viruses are carefully revived under controlled conditions to understand their behavior and adaptability. While many may be harmless, experts warn that rising global temperatures will inevitably release more unknown pathogens, one of which could pose a serious risk. Proactive research is our best defense. By studying these viruses now, scientists may develop vaccines or treatments before they become a global threat. The COVID-19 pandemic showed how quickly a virus can spread, and the next outbreak might not come from a modern disease, but from one long frozen in time. While the chances of an ancient virus triggering a pandemic remain low, the rapid thawing of permafrost due to climate change introduces unpredictable risks that scientists are only beginning to understand. As researchers work to identify, study, and mitigate these potential threats, their findings underscore the urgent need to address global warming before it unearths more than just melting ice. The past is no longer frozen in time, and what emerges from it could reshape our understanding of ancient diseases and our preparedness for the future. Thanks for joining us on this deep dive into the mysterious world of ancient viruses and the hidden threats lurking beneath the ice. If you enjoyed exploring interesting stories with us, don't forget to hit that subscribe button. What topics do you want us to dive into next? Let us know in the comments. Join us as we get animated about science here at Animated Science.